Uh, so, welcome all. Sorry for the delay. I had some meeting with the dean. So, we'll start now with our third lecture, and we continue with the ASP.J programming language. Did you have a chance to try some code out? Yeah. So now we are going to go further, and you have further examples. So all the examples that I'll be showing are available for you on Google Drive in the folder lecture 3, named lecture 3. So just after this lecture you will be able to try that code. Actually you can try try it along with me, but I think it's better for us to focus together on the meaning of the things, and then you can experiment, try things out and so. As you know, when we program things, there are ways of achieving what we need that are to a great extent generally applicable, and that have been used in different ways, but the principle remains the same, to resolve those same problems, same problems, but those problems are always a bit different, but their nature, inherent nature, is remains the same. And these things we call patterns. Patterns have been observed first in the building architecture by Christopher Alexander, but I think that the life that they had in computer science they did not have or have not had so far in building architecture. Although you might I don't know whether we can say that patterns are within our mainstream, as they are not in building architecture. But certainly we can say that it's hard to meet any software developer who does not know about, has not heard about patterns, at least about Gang of 4 patterns, but there are many more different patterns at different levels where you can observe patterns. Actually, if you attend software architecture, we talk about patterns very much there. And there are even patterns of people, organizing people. So it's not surprising that aspect-oriented programming also has its own patterns, because patterns are related on one side to the problem, on the other side to the needs that we have at our disposal for creating solutions. So they are not about some fiction, how things could be done somehow if we would be able to do so, and if we would have some, I don't know, fancy things at our disposal. So we are working with what we have, and mostly the patterns actually inspire us to use the means that we have at our disposal to build what's needed at the current moment. And I don't want to theorize about patterns in this lecture, so let's look at some particular aspect-oriented design patterns. Of course, design patterns are most powerful when they are composed with each other. But even in this most renowned or known work in our field of the Gang of 4, despite there were many other works and many other attempts and successful attempts to build pattern languages, but patterns are best known for their individual suitability and usefulness. So even without thinking of a kind of extensive application of patterns, almost everyone can find a place in their code to apply observer, for example, or visitor. And I'm certain that even such an application, although there have been some reports that this might be harmful, would be beneficial for that particular project, because some flexibility will be introduced that would not be present otherwise there. The possibility to extend the program better, like according to the ability to follow to or to keep to those good principles of design, like most prominently open-close principle. So you don't want to change things in your code, but you want to extend your code with further functionality, like in a modular way, to restate this in practical terms. So such things are achievable even by kind of a scarce application here and there of patterns. So I'm going to not to present a pattern language for aspect-oriented programming, but few interesting patterns in this field. So we'll do this through examples, and the first example we're going to look at is this one. So imagine you would need to reorder method calls according to their arguments without rewriting them in code. So this would, let's jump directly to here, to code, to see how it looks, so how the situation looks like. So this is this one, I will close this one here, close, and this one is probably the one that I need at the moment. So it looks like this. Make it bigger when we can. You see, the example is very simple. You could imagine more useful calls, or yeah, but this is a toy example just to introduce the problem or represent the problem. So we have some calls like this, and but we want to reorder them, and we would imagine we would like to order them by the argument value. But we cannot touch this code for some reason. Maybe I should have created like a more realistic example, just to convince you that that such situation could occur. But the focus here is on how to do it, whether we are able to do this or no, or not. So, what would be your idea? What do we need to do in order to do this? Where do we start? in terms of aspect-oriented programming, so you already know many things there. The essential things you know already, so you're about to become experienced aspect-oriented programmers after this lecture. We always work by capturing a certain point in the program execution.
So if we want to reorder those
Yes.
numbers, then we have to capture a call of this function. And if our number we want to insert is higher than, for example, the last one, then we will insert it after it. If it is less, then we will insert it before the first lesser one. Something like that.
Yeah, okay, so we have to manipulate them.
Something
But the
compared.
first thing is exactly, we need to capture these calls, so one by one, so we capture them. Is it enough for us to capture one and the next one and then reorder them?
Probably for
Because
many
we need
also
this one to run first. So we must capture them all.
Yeah.
So actually capture these calls and then do not, as we capture a call, we like postpone its execution. Hold this call. And let the program run further. Okay, we capture the next call and keep it. Keep the next one, and so on. So the question is, can we do this? We have this clause called proceed. So we certainly can cancel the call, capture swallow the call. Like you saw this already in the basic examples that I showed to you. So we certainly can do this. You know how to do this by using the around advice, and you never let it go further. You never introduce proceed. And that's it. But the thing is that afterwards we need to get back to these calls and run them. So we need to keep them somewhere and then reorder them, revisit them and run them in the order that we want. Like operate on them as objects. And exactly the scheme that we are going to use, or the pattern, is called worker object creation. Part of it you know from Java, but part of it is aspect oriented. So capturing of the calls is done as Nikita said. Okay, so we understand this. This is no problem with this. Okay, and we need a piece of the context, the argument value, and then we do some magic. We wrap the proceed clause in an object. And an object can be stored in a queue, whatever, some structure. You can put it somewhere and then get back to it. That's it. That's an easy part. So I created this priority queue. I didn't know about this previously, so I explored this a bit like in Java API exactly for this purpose, but you can use anything you want. So I use this one because it already orders the things that you put inside. So what I do, I just put these objects to this into this queue. And the key thing is that we are really able to put this proceed clause like this there. So it really holds a reference to what's supposed to be executed. So we create our own method, implement our own method in terms of procedure. That's the thing that you might come to this idea somehow if you would study the syntax, an extensive description of this the syntax of the AspectJ language. After some time you would come to this, but normally, even if you know AspectJ, know the things around it, you would have difficulties to come. It's like an idiomatic expression in languages. Expressions that we know what they mean, but kind of a stranger would not know this by just analyzing the relationships between the compounds. So exactly, this is how patterns surprise us, and some more, some less do surprise us. And this is quite an intriguing thing. So once we do this, it's easy, and all we need to do then to add in order to have the actual execution of this what we captured is this after advice, which actually this piece of advice actually goes one by one through this priority queue and executes the calls. Yes?
I just want to ask, when we have the execution, C.main, does that mean when we could have some code after the calls, like the C.m calls, it's going to be executed before this after clause?
Yes. So if we would have something inside of the main method.
Yeah, after those new.
Like here, something else.
Yeah.
Like. Something like this. So it does execute, as you can see. So it comes first because here we use this after style advice, and that's it. So it's not destroyed by it. After the after advice I need to actually show the aspect. So it actually does not interfere that in that way. It does not swallow. So I actually implemented within this priority queue. I forgot completely that I needed to. It's a kind of priority queue, but it's a generic thing or general thing. So you need to provide your criterion for ordering, and so I needed to implement this. But that's a trivial thing actually. So here these after advices. Or advice, pieces of advice actually do not do what this around advice does. They actually let everything execute and then they come. Okay, so this is worker object creation pattern, and this is a kind of a generalized scheme for this pattern. And it emphasizes what is important there. So this is the key part. And the thing is that you put these worker objects that you created that contain this proceed which is not completely generalized theme because you could have some arguments here depending on what you captured. And the thing is that you put them somewhere away, somehow. This is also just indicated like this. You don't maybe you don't have to put them into some queue. Maybe you would put them. I don't know what will happen to them. This is not the exact the matter that is of concern to this pattern. What is of concern to this pattern is this: that you put the proceed clause into some object, and then you can manipulate it. How do you manipulate it? Doesn't matter. So worker object creation, or sometimes this pattern is called proceed object. Proceed object. Maybe it's a better name. I stuck to this worker object creation over time, but maybe proceed object better emphasize this the nature of the pattern or the idea. So each pattern is always, so despite this is the solution like indicated in code. It's good for us because we understand code as programmers, and we can find our way even if there's no comments to it usually. But what is not expressed there is what the problem is, and I try to express this here as a conflict of contradicting forces. So it's always with patterns that you find conflicts of contradicting forces. There might be several forces there acting, like from one side or from different sides. So if you have some thing and there are some forces like this, that, I don't know what. So you might say that, okay, I will name all those forces, and that's what most pattern authors to say, this pattern describers. As this, we say that patterns are not invented; they are discovered. I think even at one point somebody had to invent something. Maybe it's a kind of what's it called a common consciousness or something like this, or whatever, where we take the ideas from, or some people think that it's a matter of individuality or whatever, but this is not that important at the moment. The thing is that the patterns are being described. So it's not just that, oh, this is a pattern. So they are being described for people to apply them. And it is important to recognize the problem where the pattern applies, and most notably this is done through the description of these forces that make you act in a certain way. And the thing is that you can name all those forces and have a long description and mystify how they are interrelated a bit, because it will be difficult if you have 3, 4, or imagine 7 forces like this. There will be like nodes, and it will be left up to the reader to guess what the conflict is. What is the problem, what is the key problem. So what you can do is what you do in physics normally when you want to put things in a balance. So you put an axis and then you count, then you see how these forces contribute as vectors there, like something like this. So you can count them on this axis all together. So this one contributes from this side, because I understood that this is the thing that these are like you select the most affected side or whatever somehow. It is so that different descriptions are possible, and you simply collect all those vectors, so this one will be longer, because if I add this one, it will be like this, but I also need to add this one, it's projected to this axis, so certainly something like this. And from this side, this one does not contribute much, but a bit, and this one like this, and so on. So I think approximately, I don't have enough space anyway to draw a longer vector. So these are two vectors like this that act on that situation or in that situation, and then I name these things. So this is like what's behind this process. But eventually you actually consciously select what is most prominent there. So although you could name more forces there are two most prominent forces that you can name. So this is no longer as precise as in physics, because it's a natural language description, but enables us to understand the substance. So here a join point has to be transferred to another context for execution, but without transferring the corresponding code. This is what we're solving. So this is a worker object creation or proceed object. So let's go to another situation. So imagine that in an organization, the workers propagate the tasks they can't solve to other workers, but they do not do so with the tasks issued by the wanted authority. So this is a kind of a more a realistic problem, or more not just a constructed thing that we need to apply some technique there, but you can imagine this in a real information system that supports like task processing or manipulation of tasks or assigning the tasks. What are the systems are called? Like I don't know, organizing systems or something like this. In a system like that, you could imagine that an organization is working like this, and that you receive some tasks, you need to do them, and if you cannot do them, you can propagate them, but the authority issued a task might become prohibited from issuing tasks at some point, because it's a kind of a thing that you do distributed work or different things, and you have like several bosses and some bosses then are capable of cutting off other bosses, because you work on important things, and this one is kind of spamming all the people around the organization, so they cut him off and then eventually talk to him and then make things work. So let's show the situation in code first, and discuss a bit how could we do this, because it's difficult again to imagine the thing without having some implementation. So this is a task propagation. That we have a task.
poistky zase na nich na dodávání, tá rozhodovačka nefunguje.
Hej?
Okay, let's call an authorized technician to do this again.
Nikto nepôjde asi, či... Vyzerá, že ide.
Hej, ide. Co to je?
One more thing. Zasenie 1.30. Počkaj, mám prednášku. Je to projektor zasenia funkčný. Asi vyhodila poistka alebo niečo. Peťo tu už bol, ale zase to stalo. Nefungujeme projektor 1.39. Vyšli niekoho, prosím ti, dobre. Okay. 10-krát nezvonilo, tak nezvonilo ani raz. Okay, so for now, let's you remember the problem, and actually I can I guess you remember the problem. So the thing is that you have some authorities. Well, they're implemented somehow as some objects that are issuing the tasks. The tasks will be again some kind of objects, and you have the workers that solve the tasks, which are again represented in the system as objects. So the thing is that suddenly you need to cut off one of the authorities who is issuing the tasks, and so to prevent the worker to propagate that task further. But the problem is that that worker does not really know about the authority. The authorities and an authority is calling calling a worker, but a worker is being given a task, but in that task it is not said who issued the task. We don't have this information within the task because simply it is not important for that worker. the system was created like this. Maybe it could have included this information, but somehow it was not included, and for some reasons we cannot manipulate this. We cannot change this. The task is simply includes just its number and maybe some data. What has to be done. So my representation of the task is such that it contains only some ID. So it's like class task, and it contains just, I'll omit unnecessary things, so some ID. There is a kind of constructor. This is public, so no set get things method. So it's not important that we have here the constructor. I want to write it. So the task simply does not have this information. This information is not transferred to the task, and eventually it is not transferred to the worker. And I'll help myself by looking at let's call it. You actually can open this code, but not everyone does the network work? Yeah, it does. So actually, this is a lecture 3 task propagation. If you go to the drive, you can open the code and look at it. So I won't have to write much. So first we were looking at this task class. If you can locate it, you will see that task looks much like this. So this is not that important. But if you look at the employee, actually worker or employee actually is a bit richer, and I imagine it has or they have some. When we speak of a class, then it's a bit. But an employee has some capabilities which are represented by some integer. An employee has an ID, and it does know about this. I call it simulation, but eventually what an employee does is just solve a task, try solving a task, or yield a task, and there are specific methods for this. That's about everything what an employee can do. And if you look at the authority class, it's which folder? Which folder? In the lecture 3 folder. Takes somehow too long for them to come here. I don't know what's the problem. Yeah, lecture 3, and then what's it called? No, task propagation. So. Je to ještě problém. A on je nedostupný. Only one employee knows which fuse it is exactly. So that's how it is. So have you managed to locate the folder? Okay. So you see. Look at the authority class. So if you don't have to open it in Eclipse. It doesn't matter, or you can open it there, but just open it as a file. And look at the authority class. So it actually does nothing, but it just issues tasks. And when you look at the employee class, so you can see that this class has 3 methods related to tasks. So it can solve a task, try solving a task, or yield a task. Yield means to give it up, give it away to somebody else. And that's exactly the thing that we want to capture. Yeah? So when you start thinking of this, when you see the actual code, it's easier to imagine what we need to do, technically. So we need to, certainly we will need to capture this yield task method. Yes, but if we capture this yield task method, we don't know what authority issued this task. So we actually need to capture also where can we find what authority? When do we? What's the part that we know what authority issued a task? Certainly not here, but at the moment of issuing a task, which is if we open again the authority class, the issued task method is the one where we will know this thing, reveal this thing. So, but we need to stop this. It's not problem in issuing, so we don't want to prevent just issuing. We want to prevent yielding a task. So the unwanted authority is fine with us if that worker or that employee can manage to do that task. So it's fine. The problem arises only when that employee is not capable of doing a task and begins propagating it. We want to cut off this. So we need to connect two levels to manage this. And how can we do this? It will be displayed just in a moment. It's all part of the show. So once again, just to make sure that we understand everything, here we have this authority. It's very simple. It issues a task, and we need to capture the number of the authority. So we want to keep this authority object and then compare things at one moment when this yielding a task comes into play, and it's here in the employee class. I just introduced some randomness here, so it's nothing too interesting.
Ja len pozerám
Okay.
zásuvky hľadom,
Aha.
že prečo to vyhadzuje.
So actually, here we have this yield task method, and the simulation is executed here. So I just needed to create some object. So you will look at this afterwards, and you can play with different settings and so on. So it's called. So you will actually be able to play with this, but this is the main method. So the thing happening here. So here is where we need to start capturing things, and how do we do this? So we could do this. We could create advanced one we see that this is a thing of a point cut construction. So this is a kind of a case of a bit complicated, more complicated point cut. The thing that we need to do is not that challenging as in the previous pattern, in the proceed object pattern. Here, the thing is in how to create the appropriate point cut. And it might be challenging and difficult to create this point cut just at once. So it is separated or divided into two things that we identified. So one side is the caller object, and the other side is the callee object, the one that is called. And so we here have this aspect that introduces this point cut of issuing tasks. So we capture on one side the authority issuing a task, and we capture the authority object. So certainly when we capture the authority object, we can interrogate it for its ID and find out what the ID it bears. And here we have the propagating tasks point cut, which captures the other side. So the other side is this yield task method, and we capture some context as well. So the employee and the task. And then we construct the overall point cut. The thing is that we need here, I will just scroll a bit, we need to include all the arguments that are there in those point cuts that are being composed here. So it's a bit longer list, but only 3 of them are there actually. And then we compose these 2 point cuts because we want to capture the situation, the intersection of the 2, but not exactly the second one. We don't want to capture just one call. We want to actually we want to capture the second one in the context of the control flow of issuing tasks, because as we learned, things can be further complicated and things can happen on deeper levels, and we don't want to capture just the first level. So we capture a complete control flow of issuing a task, just to be certain that we are capturing all these yield tasks there. And this is the composition that we do. And then the actions that we take are easy, because we have suddenly we have all the things in our hands and we can decide. So it's again the around device type, and again we can decide whether we proceed or not. So we are not putting away anywhere proceed, but we could imagine composing this with the proceed object if we wanted to put this away. So this is an opportunity for composing 2 patterns again. But let's not complicate it now. So this is just a message that we issue if we stop the propagation, and this is what we do if the things are fine and the authority is not prohibited from, like it's not on a blacklist. And let's see how it works, but actually it's best if you would experiment with this on your own. So simulation, and that's right. So the authority is set up, I think, I put some firm number here, like a wanted ID, and once we get to this number, this one will be cut off. So the generator will generate things randomly. So it might be occasionally that nothing happens, but this is yields, tries, yields. So I think this is exactly the situation. So let's write once more. So here we have it. So occasionally it will happen because I use random numbers to set up the situation. And let's look at what we've done. We actually connected two independent levels, or distant levels, like traveling through the space using those wormholes. It might be like a science fiction thing. So sometimes patterns use such poetic names. Often such names, like they sound good and are not, like we like them, but often they are not expressive enough to understand right away what the pattern is about. So what do? We created a color space, Colli space, represented by point cuts, and then capture the Colli space between the colors, control flow of the color space. So this is something that you might made an intersection like this, or try to put this all in one point cut. But if you have this situation, and if you recognize this situation, then using this pattern can help you create it and have it more like clear for maybe further modifications and everything. So it's not like all packed up in one big point cut at once, but you constructed the one that you need in a recognizable way. And then what to do, you do what you need to do. So this is a kind of, if you compare the previous pattern to this one, the one before was about the actions that are to be taken. So it's kind of this is different than this one. This is about point cuts. It's not about the actions to be taken. So it's kind of, it's as if we can distinguish between the kinds of the patterns, like this. And the forces. The calling object should be known within the context of the method being called, but without transferring it as a parameter. So if we recognize this situation, if we are in struggle with resolving such a conflict, so we know that this pattern can help us. Are there any particular questions, remarks, or anything about this? If not, let's go further. So let's look at this problem. Again, this is a kind of application-oriented problem, so not a generic one. Let's imagine we have an SMTP server represented programmatically as an object. It's being set up during the initialization of this object, so when we create it. And if an SMTP server fails, it should be replaced by another one. Like not physically, but programmatically. So we have one like a backup server, and we can start it, but we want to like introduce this in our program because it was not. Nobody thought of this before. Like all this is a separate concern simply. We do not want to affect the program. We want to keep this like the main thing is that we have a server, and the other thing is this is an exception to the situation, to normal functioning. And in some cases you might have a spare server, in some cases you might not have one. So if you do this in an aspect, you could just put your aspect in action or take it out, or like in compilation, or take it out and regulate this. So if you look at the code, that mimics the situation like this. So there is this SMTP server, just like not a real SMTP server or a class that could represent it, but it just represents what we need. So it is either connected or not. And whether it is connected or not depends on how we set these two values, which is like just for us to be able to create this wrong situation. So it will stop functioning based on other things, based on maybe some hardware problems. But eventually it will be reported to us by software means, by failing to make it occur as connected. So this is one thing. The other thing is that we have this backup server SMTP server B, which is actually just another kind of SMTP server, but kind of it's a bit different in some things. So maybe it could run. And this one actually would always work. So even if we set these arguments wrong. So it's just an example again, but the situation might be real if you imagine your implementation. And this is the actual main method where the things start to happen. So we try to start the SMTP server, a normal SMTP server, but we fail to provide the correct arguments, so it will fail to connect, and we won't have it. That's the problem. But we have this backup server, and we want to introduce it. How do we do this? Again, we're in an aspect-oriented world, so how do we start? Think about it, looking at this code. What would you do? As always, you must capture something, and I think there's not much to think what to capture. The constructor call, yeah. Not very. This one. This thing will not be complicated, like in terms of a point code. So you capture this place here, and then what do you need to do? This is where an object is being constructed that represents a server. And the thing is that you need not this object of the original server, but you want to replace it by this one. So you want to put away that object, the original one, drop it down or draw it away. And instantiate this one. That's SMTP server B, and put it there instead of this one. To make things easier, we see that SMTP server B, since it extends SMTP server, we know that derived objects or derived classes can be put in place instead of their superclasses, the objects of their superclasses. So this is, in part, this is fine. So we don't have to manipulate this. Otherwise, we could use, if that wouldn't be a case, we could enforce inheritance by using the declared parents construct that I mentioned at the last lecture, previous lecture. So, but the situation is not complicated in this regard. So let's look at how do we actually put this this object in the captured object. How do we replace a captured object by another one, which can act there even in normal Java instead of the original object, but we need to put it there somehow. So the thing is that as we understood already, we need to capture the constructors of this SMTP server class. We need to capture the arguments because we need to resolve this thing, whether or understand whether the situation is good or bad, or maybe actually we don't have to understand this. We will let the thing execute and see what happens, but we need to provide these arguments to this new object as well. So that's why we capture this context. So what we do is that we capture in a round piece of advice, we capture this constructor, and then we provide this newly created object instead of the captured one. So I've put away the actual check whether we need to do this into a separate method. So we can have methods in our aspects that help us modularize them and have a more control over how they're programmed. So this one actually gets this server object. It looks at whether it is connected, and what it does eventually, so this is the secret, it returns, if it's not connected, it returns an object of another kind of server, of a different kind of server, the backup one, with the same arguments. We can we have these arguments because we caught them here by this args boycott. This could have been put directly in the body of this piece of device, but I did not do it. So I'm showing here that I can manipulate this procedure like this. So I'm actually providing here. I'm doing proceed here, and I'm putting I would need to do proceed anyway because I need the result. So I need that object, but I did not use any variable to store this object. I'm just giving it away as an argument as it is created, because I do not need to work with it anymore. So I could have done something like this, like to make things simpler. So like this is an object, and I could have done something like SMTP server is object is received, and that's it. So this is probably more easier to understand now. So if we run this, so the first one, what do we get is that we get a reference to the server, like I'm just printing the reference, nothing much, and I'm printing whether it is connected or not. I'm printing this reference because it contains the actual the name of the class. So we see here it's B. So if I would put here 0, 0, of course that would be the original one. So in the essence, that's it. And what we did is something like this. It's called cuckoo's egg, because cuckoos are that kind of birds that put their eggs into the nests of other birds. And then those poor birds, which are typically smaller, much smaller than those than cuckoos, feed their youngsters. Actually, not really their youngsters, but they believe they are until they eventually die, because they're really small. Like parents trying to, and the son is getting bigger and bigger, and like sometimes it's 5 times bigger than the parents, and parents die out of exhaustion. This is not contained in this pattern though, but the act of putting something instead of something that was there, it's there. And you can see the scheme is simple, and again the main thing is within the body of the advice. The point that is not that fancy. And if you look at the forces, so the problem that we are looking for, or that we should recognize when we apply this pattern, is that instead of an object of one type, an object of another type is needed, but the original type must not be changed. So I should not to introduce the changes directly into the original code, and we must put a different object there. This actually, why am I showing this? I don't know. This is a kind of a generalized implementation. Like this is an implementation. If we need to introduce a change to our code somehow, we can use this aspect like this. We need to add some things there, but it's much more elaborate than that simplified pattern called scheme that I showed you previously. And this is kind of a more or less readily applicable thing. So if we recognize the situation in our code that needs to be attended in this way, this kind of change in our code needs to be introduced, we can use an aspect to do this and do not interfere with the actual code. So we will have our change implemented as a program entity in our programming language, not as a thing, as a kind of as a transaction in the versioning system, version control system. It will be like visible to us. So this is the change, and in our programming language, so we can manipulate it further. So we can work with change as a programming object, and this is actually an approach that I've been working on some time ago, and with some students, several students contributed to this aspect-oriented change realization, it's called. So this can be, and there are other schemes like this. Some resemble patterns, some do not resemble patterns. Some are more simple, like changes simply are. So there are some things that some things that can be done, could be done with these patterns in this change management approach. What I did in that approach is that I invented, and my students, we invented some schemes, some implementation schemes like this. But also the thing was that we need to recognize the problem that we need to address. So on the specification level, and this kind of change in specification occurs, or in like a reasoning about the system occurs as introducing resource backup. So there is some resource, and you need to introduce some backup for it. And if that's the case, then that problem will occur, and you can use this implementation scheme. So in a way, you will have a catalog of these specification level changes and implementation level changes, and they are mapped to each other. So like when you see when you talk about your system to the colleagues, and you understand that we need to introduce these different kinds of servers and so on, but we don't have them there, so on, so on. You will talk like this. You will not directly talk in terms of actual code. It's difficult. It's too detailed. But you need as soon as possible to have something that you can implement. And maybe you might not be versed very much in aspect-oriented programming. So such a catalog could help you cope with a bunch of problems that you understand there are some problems, but you do not know how to resolve them. You have to think hard to find these things. So this can work like this in customizing software applications. So you can have this like a basic line or main line of development, because applications are coming in different versions, and then are being delivered to different customers, and different customers often customize these applications to their needs. So somebody implements this and delivers this to you, and you customize it to your needs. But then, after a month or so, or earlier, they implement, they improve it, and deliver a different version, and you need to customize this version again. So you will like not be very happy because you will need to extract the changes from here and apply them here. You can extract them like if you like organize your code, mark your code somehow, and or you have version control system and you can compare versions and so on. But it's really a mess. Lots of things you need to do manually because you cannot really take the thing and say this entity is my change. I can take it like this and apply it somewhere else. But with aspects, you can actually do this. So you can implement the changes as aspects and apply them. Maybe we will need to adjust some things, of course, because the context has changed, but most of it will be applicable. So this is this aspect-oriented change visualization that I mentioned. And I have one more thing. I can leave this for the exercise, but let me just introduce what you can observe in the code that's provided with respect to the observer pattern. This is not an aspect-oriented pattern, so I'm not introducing here observers and aspect-oriented pattern. This is a traditional implementation or model scheme of the observer pattern. So you know that this pattern is about managing the objects that would like to observe the state of some subject, but that subject does not want to bother with these observers very much. So all that is acceptable is that they will get some notification, but it's up to them to assign for the notifications. So that's why you actually implement a mechanism for attaching these observers to the observed object, which we call subject, and then this notification mechanism. Then the observing objects will update themselves accordingly. They can even maintain a part of the state within themselves and so on. But that's something that you know. The thing that you might not have thought about up to now is that can the logic of the observer design pattern be decoupled from the application logic? So certainly you can look at this. This is a mechanism that we introduced inside. So the subject does its own things. So I did not put these methods here. So the subject is something that some of your application objects, and it does some useful things. For example, it could be a temperature sensor, and your observer object could be displays, different kinds of displays that display this temperature. So what this subject does is to measure the temperature. Why it should bother with attaching and detaching and notifying some crazy temperature displays, different kinds, and there can be various kinds occurring over time. We do not want to clutter its code with this, and that's where the aspects come into play. These are the conclusions, but I will show you just that the code that you can look at is provided in two versions, so an aspect-oriented one and the object-oriented one. So this is the object-oriented implementation you can look at first. Like digital temperature, the temp display is the thing that I want to show you. So this is an interface of a display, and most notably this is the interface of the temperature sensor, and you can see add display, remove display, notify display. So, these are all the things that we do not want to have here. And if you open this aspect-oriented implementation, not exactly. So this is temp display, temp sensor. It looks like this. So look at this and look at that. So we got rid of this, and what we did is what we did is implemented within this one aspect. So we will not study it in detail now. So just look at it. It's a short aspect that introduces things that we need to introduce and puts them into play by using two pieces of advice, I think, or is it just one? Just one actually, because we just need to put these notifications into force. So actually this means that we can take out the mechanism of some object-oriented design pattern, implement it as an aspect, and then use it in a general way to some extent. There might be hope for this, but even if you are not capable of to use it in a general way to other applications, we will have this mechanism separated from the application logic, the essential application logic. And if we decide to implement this mechanism differently, we could manipulate this aspect, or we could decide for some other mechanism, and we will not touch anymore the application code. So this is not an aspect-oriented pattern. This is aspect-oriented pattern, object-oriented pattern re-implemented in an aspect-oriented way. So what we saw here today is that we could we saw three aspect-oriented patterns: worker object creation or proceed object, wormhole, cuckoo's egg, and we saw this how design pattern logic can be decoupled from the application logic. I did not show this thing here, the last one, that aspects regarding the aspect instantiation, but if you look at that lecture 3 folder, you will find there this thing, instantiation, and you will find there different ways. This is an example to apply this aspect and to follow how these instantiation modifiers change what happens, because you can have an aspect per virtual machine for the whole program, one aspect object, but you can go all the way down to having aspects as shadows of your objects. So they are automatically instantiated as soon as you create different objects. Probably you won't bother with this very much if your project is not concerned with aspect J, but it's just a fun thing to know about, and maybe to try this example. And if you will need any advice on this, or you would have any questions, so Victor and Jakub will be here and we can discuss this even next time. So I will not go into details with this. I did this for the exercise. So let's finish like this. But do you have any questions? So about taking the chairs are moving, so we know that we should end. So thank you for the attention. That's it. We will meet next time, the same time.